Good day once again, ladies and gentlemen, and we are back again together. Please don't be alarmed when you hear the sound of rain or thunder outside. We're blessed with a rainy season in South Africa, and we thank God for that. All right, so today I'm going to just be looking at the multiple choice section. I know I've been dishing out quite a number of solutions to the past preliminary exam questions, but I should have actually started with the multiple choice section because that was the first one. So yeah, if you haven't subscribed, please be part of our channel. And by the way, for those of you who need assistance with mathematics or physical science, please, you're more than welcome to get in touch with me. And my email address is info@mlungisinkosi.co.za. All right, now let's have a look at it quickly. Let's start with the first one. They say to us we've got inertia is a property of an object whereby the object, okay, so we needed to complete that statement. Remember that when we talk about inertia, that's the resistance, okay, of an object to either a change in its state of rest or motion. So in this case, I'm going to go with, okay, so the first one says needs a force to accelerate. That cannot be true. That would be Newton's second law. This would be comes to rest when the force that is set in it in motion is removed. Again, that's a function of Newton's second law. It has to do with resultant force. Has kinetic energy. Well, look, that's not too bad an option. Of course, we are talking about something that is in motion, but we need something that talks about the resistance of it to change in motion, right? So let's look at D. It says is not able to move. I think I would go with D as the most correct answer. And that's the thing about multiple choice. You know, sometimes you need to look at, the solutions that are given to you and, go with what you feel is the most correct, right? Speaks to the situation the most. Okay, so that's the first one, 1.1. Okay, the second one, they say a box of mass M rests on the floor of a lift which accelerates upwards. The lift's acceleration is A, so they're telling you that the lift is going up, okay, due to and the acceleration due to gravity is G. They say the net force on the box is equal to. Now, so I want us to quickly do this. Let's just try to illustrate this, okay? So what's happening here? We've got an object, okay, that is in this lift. So in this case, there's our object. We know that it has a mass M, right? So now they said that the lift's acceleration, okay, is A. So we know that in this case, this object or this box is being actually pulled up, right? Okay, so we know that it's really going to go up, but we also know that there's a force due to gravity. In this case, we know that gravity will be mg. Okay, now in this case they wanted to find out what the net force of this guy will be, right? Let's call that force F. Okay, so how do we express net force? We know that F net will be equal to MA, right? Okay, so the trick in this question is that how they gave you those answers there. So there are two things. If they were looking for the force F, okay, we'd really need to express that. Of course we would then say F is the force F minus the force of gravity. This is equal to MA. But what did they say to us? They are looking for the net force. Simply, what is net force? F net is the mass of the object multiplied by its acceleration. They told us that the acceleration is A, so the correct answer there should be A. I hope that makes sense, right? Okay, so you didn't need to actually, go into the intricate details of that. Okay, They say a learner drops, okay, that's 1.3. I hope 1.2 has been clear. They say a learner drops an object from the 15th floor of a building. 1 second later, the learner drops another identical object from the same position. As both objects are in free fall, okay, we know we're dealing with free fall projectile motion here, vertical projectile motion. They say the distance between them will, okay. Now, what should happen to the distance between them? So I will try and express how would I get the distance of the one. Let's take delta y, which is vi delta t plus 1 over 2 times a delta t squared. Okay, so assuming, of course, they told us that we're dropping them, so in this case it tells me that my initial velocity is 0, so I've got half a t squared. Now I want you to think about it. Okay, for the displacement of the one, okay, what would be the value of the acceleration? It's 9.8, and it's 9.8 for both of them, and in this case it's a function of time. Now think about it. So it means that as they fall, okay, when I calculate the distance of the one, I'll say half a t squared, so whatever time that is, and the distance of the other half a t squared. So in a sense, because their accelerations are the same, okay, and the difference in time in a way is kind of the same, so in this case what happens, it means that the distance between them, I would say it would actually remain the same, right? So in this case I would choose D as my final answer. You can try and work it out. You can take a scenario and check it, and you'd see that should basically be true, right? So 1.4, they say a trolley with mass m is moving with a constant horizontal velocity v on a frictionless track. Okay, so they say a block of mass m is dropped onto the trolley from above, right? So here's our trolley here. So it was initially moving on its own. Let's say it's moving that direction, and then now we drop, so afterwards, we drop an object onto the trolley. Okay, so there's our object over there. Okay, remember the mass of the trolley was mass m, and remember it was also moving at v, right? I always find it helps to kind of have a scenario, or just to draw something for yourself there. It helps with getting a solution, finding a solution, right? So in this case we're going to say, well, we know it's a frictionless track. They say a block of mass m is dropped, so now, meaning afterwards, the block and the trolley have got a mass of 2m, right? Okay, and they want to know what will be the final velocity of the trolley and the block will be. So we're going to use the principle of conservation of linear momentum. So I'll say, well, the sum of their momentas before collision, okay, initial, will be equal to the sum of their momentas final. But I want you to think about it. What was the momentum of the object before collision? Okay, so this was stationary, and in this case the trolley was moving on its own. So the momentum before was just the momentum of the trolley, so it's going to be mv. Okay, but what happens afterwards? It's the trolley together with the with the brick or with the object. So now you've got 2m. Okay, now we want to find out what will be this new velocity. Let's call it vx. Okay, we're trying to find vx in terms of v, right? So what simply happens there is that I can just divide by m on both sides, and what would be my vx? Vx would actually be v over 2, and it makes sense. The heavier that object would be, the lesser the velocity would be if we're going to keep momentum the same. So our correct answer there should be C. Okay, Right, I hope that you get that. Okay, right, let's move on to the next one. Okay, let's get rid of that. Okay, so in 1.5, they say we've got an electrical motor that has a power rating of 1.2 kilowatts. They say in 1 minute, the amount of energy, the amount of work done rather by the motor in joules is. Okay, so what we need to find out, they've given us the power rating, okay, and what we also have now is that they want the work done. So how do we relate work done and power, right? We know that power is the rate at which work is done, so it's work done divided by time, right? So we want the work done, so this should be the energy, okay? Want the work done, this divided by change in time, okay? So work done would be power multiplied by that change in time. So if we look at this, we're given a energy of 1.2 kilowatts, so this would be 1200 watts. Remember, kilo just means 1,000, so you say 1.2 multiplied by 1,000, okay, multiplied by the time. In this case, you were given that time as 1 minute, okay? So in this case, what we'd do is we'd need to multiply that by 60. Remember that time should be measured in seconds, okay? Right, I'm just going to take that up a bit. Okay, so all we need to do, just some mathematical gymnastics there. And I get an answer of 72,000. Okay, and that's in joules. So the correct answer there should be D. So answer to 1.5, that's D. Okay, and then the next one says a car travels at a constant velocity towards a stationary listener. Okay, certainly here we are talking about the Doppler effect, right? They say the car's hooter emits a sound at constant frequency as it approaches the listener. Okay, which one of the following statements regarding the frequency and the wavelength of the sound of the hooter as observed by the listener is correct? Right, now please remember, what should be the most important thing? They said to us the car's hooter is emitted at a constant frequency as it approaches, so it's moving towards the listener, right? So let's draw that scenario quickly. So if this was our listener, okay, there's our listener with the ears, okay, and here's the car moving. I'm not going to draw the actual car. So as it moves towards the listener, remember, on the side that it's moving towards, what would happen to the sound waves? That be compressed, okay, but where it's moving away from, you'd see that the sound waves would be stretched there. Okay, I hope you can see that. Okay, so they're compressed, so the wavelength on this side would be smaller, whilst the frequency, remember, the smaller the wavelength, the higher the frequency, right? So what would happen to the sound that is observed by the listener? Okay, let's look at our options. They say both frequency and wavelength are decreased. That's not true. All right, both the frequency and the wavelength have increased. Nope. The frequency has decreased. So the frequency has decreased. So remember, we said our wavelength is smaller, right? So this one should be the frequency has increased while the wavelength has decreased. I would go with D once again. Okay, let me just write it over there. So 1.6, the most correct answer there, or rather, let me say the correct answer should be D, right? Okay, moving right along. They say, okay, the next one. Now we've got the number of excess electrons, okay, which will cause the charge of -8 microcoulombs. Look at that. On a sphere is equal to. So in this case, remember, when we've got electrons that are in excess, all right, we know that we're going to have a negative charge, right? So now, how do I find out how many electrons are in excess? I hope that you'll be able to follow on as I write all of this down, I'm going to give the answer finally. But how do we calculate number of electrons? Well, we say number of electrons, it's going to be the charge divided by the unit charge of an electron, isn't it? So in this case, what are we going to have? Our charge is -8. Remember, micro is times 10 to the power -6. So that's times 10 to the power -6 divided by, what's the unit charge of an electron? That's going to be -1.6 times 10 to the power -19. Okay, and all we need to do is just calculate that value. So we get an answer of 5 times 10 to the power 13. So that would be the number of electrons, right? Okay, just remember, ladies and gents, so if they had to give us a positive charge, what you'd need to do is you'd divide by a positive 1.6 times 10 minus 19. Why? Because you cannot get a negative number of electrons. It's a physical count. So in this case, that would be the number of electrons. It should always be a positive number, right? Okay, so our correct answer there should be B, and that's our answer. All right, let's go to 1.6 quickly. They say we've got 4 identical light bulbs, 1.8 rather. 4 identical light bulbs are connected as shown in the diagram below. So here we are, we've got those, we've got a parallel combination there, okay, and we've got that series combination there. All right, now they want to know how does the brightness and the potential difference of L4, so which means it's this guy over here, okay, compare with the brightness and the potential difference of L1. Okay, so I would imagine when we get to that point there that the current obviously between the two, okay, so first of all, from positive to negative, so the total current passes across L1, okay, so in this case I know it's the total current that passes there, and what happens to the current when it gets to this node? I know the current would divide, right? So half of the current would go there because they are equal resistors, okay? So remember, when we talk about brightness, this has to do with power. Now, they told us that the resistors are identical, meaning that their resistance is the same, right? But think about it. How do I relate power, current, and resistance? So it's going to be I squared multiplied by R, right? So R is the same, but what happened? I know there's more current on L1 than there is on L4. So in this case, what happens? It means that the power on L1 is greater. So remember, brightness has to do with power. So I know that L4, okay, so they said, how does the brightness and potential difference of L4 compare with the brightness of L1? Remember, we are comparing L4 to L1, so it means that L4 would be less bright, so the brightness would be less, okay? But again, we know that V is equals to IR, isn't it? Okay, so in this case, once again, resistance is the same, current is more, so in this case it also means that the potential difference should be greater the potential difference of L1 should be greater, right? But remember, we are comparing L4 to L1, so L4 should have a lesser brightness than L1. It should have a lesser potential difference than L1 as well. So my answer would be less and less, and so that would be A. I hope that makes sense. Okay, right, as we move on to the next one, okay, so we're trying to find we're almost right at the end there. Really, I hope that you're able to enjoy this. Okay, so they say, which one of the following devices cannot operate with both DC and AC currents? Okay, the answer to that is quite simple. Okay, so if you look at all of the other devices, if you look at an electric kettle, a light bulb, and an electric fan, all of those are just devices that you can use. But if you think about a transformer, okay, remember that a transformer can only work with AC and not DC. So in this case, our correct answer is B. Okay. All right, and then the last one, they say in an experiment on the photoelectric effect, okay, scientist shines a green light on a metal surface and observes that electrons are ejected. So we know that in this case it means that green light in this particular case would have a frequency that is above the threshold frequency, okay, because here we've got electrons that are ejected, okay. And they say later the scientist shines blue light with the same intensity. Now, all we need to do is just please remember. So if you think about Roy G. Biv, right? Roy G. Biv. Okay, we know that frequency increases going that way. Okay, so I know. So I'm comparing blue with green. So blue light should have a higher frequency than green light. Okay, so as a result, I know that the electrons in blue light would actually move with greater kinetic energy, right? So let's look at the question. What are they asking us? They say later the scientist shines blue light with the same intensity as the green light on the same metal surface. So it means that our work function should be the same. So they say which one of the statements below will be the correct observation as a result of the change, right? As I was explaining, we've now changed from blue from green. So in this case, because blue has got a higher frequency, right, the work function, remember, remains the same. It's the same metal. So therefore it means that the kinetic energy of those ejected electrons should actually be higher, right? Okay, so they say the number of ejected electrons per second will increase. Remember, that's a function of intensity. Okay, so intensity should be the same. So in that case, that will not necessarily be true. Okay, remember that when we talk about intensity, and please, for those of you who may be wondering what I'm talking about, please go and visit our lesson on the photoelectric effect. I tried to explain that quite nicely there, right? So if it talks about ejected electrons per second, okay, that's a function of intensity. But let's look at the next one at C. They say the maximum kinetic energy of the ejected electrons would increase. I would tend to agree with that. So my answer for 1.10 should be C. Okay, right. I think we've gotten to the end. Oh, fortunately, I've been able to squeeze everything in here. I know it looks messy, but obviously, if you are following, you should be able to know what belongs where. All right, so please don't forget to subscribe. Okay, I think one other thing that I'm trying to prove, ladies and gents, is that multiple choice is not, it's not a eeny, meeny, miny, mo, picky, type of scenario. You should be very intentional in how you pick your answers, okay? And please just try and practice this more, all right, so that you can be able. It's a great way to revise, by the way. So just continue to try and answer those multiple choice questions, right? Yeah, and we've gotten to the end. And please, if you haven't subscribed, please do the right thing, and please continue to tell more people. And I see that we've surpassed the 15K number. Yay! Okay, thank you so much, guys, and I'll see you guys next time. Sharp, sharp.